Welcome to 8.5. So we're going to start with 8.5 and we're going to do that very briefly. And then after 8.5, we're going to transition to reviewing for test 3. So 8.5 covers a couple topics, but the part we're going to focus on is the part where we look at quadratic inequalities. This is one of those topics that UAA requires. It's not a very central topic, but there is a lot of review in it of central topics, so it's still a worthwhile use of your time. The two problems I'm going to do right now are number 16 and 20 from the study set, and this will prepare you to do self-check questions 1 and 2. Okay, so here's number 16 from page 736. We're to solve this quadratic inequality. It's a quadratic expression here on the left-hand side and an inequality sign, hence quadratic inequality. So it's quite simple. What you're going to do is you're going to start off by factoring. And then once you factor, you're going to consider, if this were an equation, how would I solve it? Okay, so let's look at the equation that corresponds to this inequality. This equation, by the zero factor property, is solved, and you get x equals 2 or x equals -4. So what we're going to do with these two values is we're going to make a number line. Okay, so here's my number line. And in general, you always want to include 0 in your number line. And that one doesn't work, so let me try and find a different marker. Okay, this one will have to do. Okay, so here's my number line, and if we don't pay attention to 0, what we have are 3 regions of the number line. You have the numbers that are greater than 2, so that's one region. You have all the numbers between -4 and 2, that's a second region. And then you have all the numbers that are less than -4. So what we want to do is determine for these 3 regions, which region has values that will make the original inequality statement true, and which regions have values that will make the inequality false. So you just pick any representative number from each region. So for instance, the region over here to the left of -4, I could pick the value -5, for example. For this region right here, I could pick 0. 0 is a good number to pick. And then for this region to the right of 2, I might pick the number 3. So the idea is you want to pick a representative value from each region. And you want to pick a value that's easy to plug in. So don't pick some fraction or irrational number. And you also can't pick a boundary number. Okay, so -4 and 2 are boundary numbers. You're not going to pick those. So now each region has a representative value. For the region over here, -5. For this region right here, 0. And then this region over here is 3. And we're going to plug these into the original quadratic inequality and see if we get a true statement or a false statement. So if you plug in -5 up here, what do you end up with? You have -5 squared plus 2 times -5 minus 8 less than 0. Okay, so that's 25 minus 10 is 15. Minus 8 is 7. So by plugging that in right there, I ended up with the statement 7 is less than 0. And 7 is less than 0 is a false statement. So that means that this region over here is a false region. Okay, now let's try this again, now with plugging in 0 as a representative number. So now I'm going to plug in 0. 0 represents this middle region. 0 squared plus 2 times 0 minus 8 less than 0. That statement simplifies to negative 8 less than 0, and negative 8 less than 0 is a true statement. Okay, now we try this again with 3. 3 represents the region over here. So 3 squared plus 2 times 3 minus 8 less than 0. That's 9 plus 6 is 15 minus 8 is 7. We end up with a positive 7 again. 7 less than 0 is false. These are probably both 7 because of symmetry. They're both 1 away from a boundary number. The vertex here would be at, what, negative 1? Yeah, negative 1 would be the vertex. Anyway, so what I have here is a false region, a true region, and a false region. Graphically, if you were to fill in a number line for an inequality, since this is a strict inequality, it's not less than or equal to, it's just less than. What that gives you is the open circle. Okay, sometimes we use the open circle, sometimes we use the parentheses. So you could graph the exact same thing with parentheses instead. Here, I'll show you. So whether you graph with the parentheses or the open circles, remember that the parentheses and the open circles mean the same thing. It means that we don't have an equal sign here. Okay, so then that's the solution area. This is the true region. And so for your final answer, you want to represent it in using interval notation. And for interval notation, what that means is that we are going to start at negative 4, but not include negative 4, and go all the way to 2, but not include 2. So your answer is the interval from negative 4 to 2. That does look like a point. It looks like x comma y, but in this context, that's an interval. And it's the interval from negative 4 to positive 2, not including the endpoints negative 4 and 2. Okay, so that's question 16, and that should help you with self-check question 1. And next we're going to look at question 20, and we'll go through this one a little quicker. Okay, here's question 20. So the first thing we did in question 16 was we factored the quadratic. To factor this quadratic, though, we need to have everything on one side. So just put everything on one side and then factor. And if you were to solve the corresponding equation, the equation looks like this. And when you solve that equation, you end up with x equals negative 8 or x equals 9. So these are the two numbers that we're going to use on our number line. And we always want to include 0. Okay, so now we have three regions. We have a region to the left of negative 8. We have the region between negative 8 and 9. And then we have the region to the right of 9. And for each of those regions, we need to pick a representative number. So to the left of negative 8, we could pick, for instance, negative 9. To the right of positive 9, we could pick a number such as 10. And since these are both 1 away, we might end up with the same value when we plug them in. And then here in the middle, we'll just use 0 as our representative number. And now we're going to test each of these 3 regions. We're going to see if they're true or false by plugging in these values back to the original inequality. So let's start with -9. -9 squared minus -9 greater than or equal to 72. So this is 81 plus 9. 81 plus 9 is 90. So 90 greater than or equal to 72 is a true statement. Next, we're going to plug in the representative from the middle region, which is 0. So 0 squared minus 0 is just going to be 0 greater than or equal to 72, which is a false statement. And then lastly, we plug in 10. 10 squared minus 10 is 90. So 90 greater than or equal to 72 is true. So when we have true on the outside, it means that we're not shading the middle area. We're shading the regions going outward. Okay, so that's the solid dot in this case because it's greater than or equal to. It's a solid dot, and it's going to go to the right, and then over here, solid dot, and go to the left. Now the other way of graphing, instead of using dots, the open circle, and the solid circle, as in the previous problem, you can also graph by using the interval notation. So that would be, blanking out, these brackets. Yes, there we go. So we're going to have, instead of parentheses, we're having this very rigid looking bracket. Go to the left. Go to the right. And as an interval, what that is we're going from -infinity all the way to -8. So -infinity, remember infinity and -infinity always use parentheses. -infinity to -8, united with +9 all the way to infinity. Okay, so now that we're done with our short lesson on 8.5, we're going to do a review for test 3. So I'm going to work through the problems in MyOpenMath. The first problem is a graphing problem. So for question number 1, this is a matching problem. You are given that the original function is y is equal to the square root of x. That's what that looks like. And then there are 4 other graphs online. They're color-coded. There's a green, an orange, a blue, and a red graph. And you just need to be able to match which one goes with which. So the one up top here is going to be a shift up. So because I'm shifting up, I'm going to take my original function and I'm going to shift it up 2. So that's +2. The one below is shifting down 2. So this one is y is equal to the square root of x minus 2. Notice that the +2 and the -2 are outside the function because with vertical shifts, you're going to go outside the function. Now, when you shift to the right and the left, a horizontal shift is inside the function and it's counterintuitive. So when you shift to the right 2, you're going to have the shift inside the function and it's going to be counterintuitive. So a -2 actually tells us to shift right 2. And to the left, this one is going to be x +2 inside. So the plus inside the function actually moves to the left, and the minus inside the function moves to the right. Remember, horizontal shifts are counterintuitive, whereas the vertical shifts are intuitive. So that's question number 1. For questions 2 and 3, these are also multiple choice. I'm just going to write them as if they were short answer. But what you want to do is take these current forms, this is in rational exponent form, and rewrite it in radical form. So when you have the 11 in the numerator and the 14 in the denominator, the 14, the denominator, is actually the index of the radical. So this one becomes the 14th root of x to the 11. So this is a really easy question. Just memorize that the denominator determines the index, okay? In this case, notice that the 7 is separate from the x. It's not attached using parentheses. I added this little multiplication dot for effect. But the key point is to notice that the 7 is not attached to the x with parentheses. So the 7 is actually out in front, and x to the 1/2 power is the square root of x. So those should be really easy problems that you can just get immediately on the test. If you run through the practice test, that will be simple for you to do. For questions 4 and 5, we're going to look at the multiplication and the quotient rules here for exponents. So what we want to do is simply combine these through addition. This is short answer. We're going to basically just take the 1/2 and the 1/5 and add them together. And you don't have to show any work. This is short answer, but 1/2 and 1/5, in order to combine these, you need to have common denominators. 1/2 is the same as 5/10, and 1/5 is the same as 2/10. So 5/10 and 2/10 is 7/10. So your answer online would be x to the 7/10. Don't forget to use the preview button so that you can make sure that your answer is written in the correct format, and so you don't make any typo mistakes. For the quotient, instead of adding the exponents, you subtract. So we have x to the 5/6 minus 4/5. To combine these, again, we need to have a common denominator. So that's going to end up being, this is the same thing as 25/30. And this one is the same thing as 24/30. So 5/6 minus 4/5 is 25/30 minus 24/30, which is 1/30. So that's the answer there to number 5. Again, these can be very quick problems with doing some practice on the review. The practice test online would allow you to be able to answer these questions very quickly if you can run through those a couple times. Next, we have questions 6 and 7. Question 6 is short answer, and question 7 is multiple choice. For both of these, we are simplifying these radicals. So there's no work required. You can just show work on your scratch paper that you need. When you simplify this radical, one approach is to split it into 2 separate radicals where you put all of the perfect squares in one radical and everything that's left over goes in the other one. So 36 is a perfect square. J to the 7th power splits into j to the 6th times j to the 1st. And a to the 8th is already a perfect square. In order for an exponent to make a variable a perfect square, the exponent only needs to be even. So this simplifies to 6j cubed a to the 4th times the square root of j. So pretty straightforward. For the cube root problem, you are getting to have a multiple choice problem. We can use the same approach, though. We're going to split this into 2 separate radicals. 64 is 4 times 4 times 4, so 64 is a perfect cube. X squared is not. We need to have the exponent be a multiple of 3 in order to go into the perfect cube radical. So now we're going to simplify this more. This is 7 times 4 times the cube root of x squared, and that fully simplifies to 28 cube root of x squared. And this is multiple choice online, so you can easily just select the answer. You don't have to show any work for that one. Okay, so for question number 8, we have to multiply together two radicals. In this case, it's a fifth root. When you multiply these together, you just get to combine them into one fifth root. So this is the fifth root of 27 times 9. And x squared times x cubed. So you can go ahead and combine those together, but one thing I notice here is that both 27 and 9 are both powers of 3. So it may be useful to rewrite 27 as 3 cubed and to rewrite 9 as 3 squared. Of course, x squared and x cubed come together to be an x to the 5th power, and you can notice here that then these will be 3 to the 5th power. This is short answer, so you can show whatever work you need. No work required. So since I have 3 to the 5th power and I need the 5th root of 3 to the 5th power, that's going to be 3. And the 5th root of x to the 5th power is x. So that simplifies to 3x. For number 4, we need to use the distributive property. So we're going to multiply 2 root 5 to 3 root 15, and then to root 10. So the 2 times the 3 becomes 6. Numbers outside the radical will multiply to other numbers outside the radical. Numbers inside the radical, as long as they're both the same type of radical, and in this case they are both square roots, they can multiply the numbers inside the radical together. So 5 times 15 is 75. Here, this is a 2 times 1, right? Because there's only a 1 on the outside of this radical. And then 5 times 10 is 50. So that's your first step. And then after you get here, you're going to want to simplify these radicals. So root 75 splits into root 25 times root 3. Root 50 splits into root 25 times root 2. Root 25 is 5. This becomes 30 root 3 plus 10 root 2, and you cannot combine any further. This is also short answer, so just show whatever work you need on the scratch paper to get this answer right. There's no partial credit though, so it's just whatever you can come up with on your own. Make sure you do not combine these any further. A square root of 3 and a square root of 2 cannot be combined. Number 10 on the test is the first one where you have to show your work. So in the version of the test that I've pulled up, I have the square root of 80 c to the 4th into the 8th power divided by the square root of 25 c to the 10th into the 6th. So let me show you the work that you're going to show. Okay, so you're going to combine these into one radical, and you can reduce the fraction at the same time. So 80 divided by 25. 80 is divisible by 5, right? So 80 divided by 5 is what? 16. And 25 divided by 5 is also is 5. Now c to the 4th divided by c to the 10th gives you a c to the 6th left in the bottom. We get that by 4 minus 10 is negative 6. And if you have a c to the negative 6, it's going to go downstairs to the basement. And then n to the 8th divided by n to the 6th is n squared. So once you've fully reduced your fraction, Now you're going to want to simplify the numerator and the denominator. You can simplify the numerator and the denominator separately. That's another option. So I'll show you that option next. I'm going to show you two different ways of doing this same problem. So this is the reduce first, then simplify method. So if you reduce first and then simplify, the numerator, the square root of 16n squared, is 4n. And the denominator, you have a square root of 5 times c cubed, right? So 16n squared and c to the 6th were all perfect squares. Square root of 5 is the only number or variable that has that's not a perfect square. So we need to rationalize the denominator, multiply by root 5 over root 5. And this will then give us 4 times root 5 times n. Make sure that the n is not under the radical. You're welcome to put the n out in front. Sometimes people do that. Multiplication is commutative, so you can write it whatever way you want. Root 5 times root 5 is 5, and then we have c cubed. So you can do it that way. That's the reduce first and then simplify method. You can do the exact same problem again, a different way. So if you want to simplify first, to simplify this radical, you're going to split it into 16 c to the 4th n to the 8th times the radical 5 over, and this is all a perfect square, 5 c to the 5th n cubed. And then right here, this would simplify to 4c squared n to the 4th root 5 over 5c to the 5th n cubed. And this right here is optional. You can, okay, so this one right here is optional work. You can go straight from here to here. So if you do not need to split into two separate radicals in order to simplify your radical, you are welcome to go straight from here to here. Now once you've gone from here to here, then you want to simplify your fraction. This is the reducing part, right? So you have a 4 over 5, c squared over c to the 5th, you're left with c cubed in the denominator, n to the 4th divided by n cubed, you're left with an n to the 1st power in the numerator, and then square root of 5. So both of these answers are equal to each other. This answer right here and this answer right here are the same thing. I wrote the n in a different order, but you can do it either way. So which way is better? Whenever the denominator is already a perfect square, I tend to simplify the radical first before I reduce, because that saves you the trouble of having to rationalize the denominator. But if you just want to stick with the same steps over and over again, it's usually better to combine into one radical and reduce inside the radical first before you simplify the radical. That's usually better. I only deviate to the second method when the radical in the denominator is already a perfect square. That way you don't have to rationalize the denominator. But it's up to you. Both of them are legitimate ways to show your work for the test. You just need to make sure that you pick one of those two ways and make sure you show all of the work, okay? So for the first one, this is all of the work that you would want to show. And for the second method, you don't have to show this one optional step. You can go this way and reduce that way. But you have to pick one of those two methods to show your work on the test. Okay, so here we have question number 11. Question number 11 does not require work on the test. It's a short answer. So what I want to do is simplify each individual term first, simplify each individual radical first, and then combine anything that can be combined. The first term, 4 root 5, is already completely simplified. Then we come to the square root of 343. And you can just check, is 343 a perfect square? No, it's not. So then you think to yourself, what divides into 343? And you can just start testing numbers. So 343 is divisible by 7. And you'll see that you end up with 7 times 49. So 49 is a perfect square. And 7 is your leftover radical. Square root of 20, of course, splits into root 4 times root 5. So now we have 4 root 5 minus, this is 4 times 7, right? Square root of 49 is 7, so 4 times 7, 28 root 7. And then this is 3 times 2, because the square root of 4 is 2, so 3 times 2 is 6. And now we're going to check, since we have a radical 5 and a radical 5, both of these root 5s can be combined. 4 root 5 plus 6 root 5 is 10 root 5, and then minus 28 root 7. So that's your final answer for that one. There is no work required. So here's question number 12. It does not require any work on the test. You are rationalizing the denominator. So this is the same thing as the square root of 3x over the square root of 10. Both of those radicals are fully simplified. Multiply by root 10 over root 10. And now the numerator is the square root of 30x, and the denominator is 10. So that's it. It's just a simple short answer question. Number 13 does require you to show your work, and this one is another rationalizing the denominator that's a little trickier. So let me show you number 13. Okay, so you want to split this into a numerator and a denominator, and the square root of x cubed, you can simplify that into x root x. And then you're going to multiply by a root x over root x. So this gives you the square root of 10x over x squared. So an alternative way of doing this problem is you can ask yourself, what do I need to multiply this by, this denominator by, to make it a perfect square? Well, you can multiply by x cubed over x cubed, but then that's going to require you to do some extra simplifying work. The most efficient way of doing this problem is to say, if I simply multiply x cubed by x to the first power, x cubed times x to the first power is x to the fourth power, and x to the fourth power is a perfect square. You do not need to put these first power exponents there. I just did that for effect. So then this simplifies to the square root of 10x over x squared, and you're done. So you could do it this way, and that would be the only work you would show, is just show multiplying by root x over root x, and then you automatically have your answer, because x cubed times x to the first is x to the fourth, and the square root of x to the fourth is x squared. Here's number 14. Number 14 also requires you to show your work. So the first thing you're going to want to do is make the observation that this is a radical equation. The way we solve a radical equation is we get the radical all by itself, and then we're going to square both sides. That is because in this class we're only looking at solving radical equations with a square root. So of course if you had a cube root you would have to cube both sides. But we're only doing square root. So it will always be the same technique. You want to get the square root all by itself, and then you're going to square both sides. So start by adding 4 to both sides. Okay, so after you add 4 to both sides, now you have a square root equal to a non-negative number. And so once you check that this is non-negative, you can proceed. If this is equal to a negative number, then there's no solution. But now you have a square root set equal to a non-negative number. You're going to show the work of squaring both sides. Make sure you show that work. So when you square a square root, you get what's underneath the radical. And then 3 squared is 9. Next, you add 18 to both sides. Divide both sides by 3. And when you get your final answer, plug it back in. Make sure it works. 3 times 9 is 27. 27 minus 18 is 9. The square root of 9 is 3. 3 minus 4 is negative 1. So you can actually plug it back in and show your work if you want. And check that this is actually true. Once you check it's true, then you know that you have your correct solution. What's required, though, is just this part right here, okay? So this is the part that's required. Your check, you can do that in your head or on the calculator. You do not have to show that as part of your work. So that's question 14. And then question number 15 is also one where you have to show your work. So let me get that one up next. This one is also solving a square root equation. So as in the previous problem, before we can square both sides, we need to get the radical all by itself. So you want to add 2 to both sides. Once you add 2 to both sides, then you square both sides. Show squaring both sides, and make sure you use parentheses. That's very important. Now notice here what I have is I'm going to square a binomial. The left-hand side is easy. When you square a square root, you get 2x plus 12. You can very easily get this problem wrong if you forget that when you square a binomial, you get a trinomial. X plus 2 quantity squared is not x squared plus 4. If you make that mistake, you'll get most all the problem wrong. Okay, so it's really critical that you remember that this is x plus 2 times x plus 2. Foil if you have to. Write it side by side if you have to. But you should end up with a trinomial. When you square a binomial, you always get a trinomial. Okay, so once you get down to this line, you realize that you don't have a linear equation like you did in the previous problem. You actually have a quadratic equation. So you need to solve the quadratic equation. We solve the quadratic equation by getting everything on one side. And then we use the zero factor property. And then once you get here, you need to plug back your answers into the original equation and see if they work. So testing the first one, 2 times 2 plus 12, that's going to be the square root of 16, which is 4. 4 minus 2 is 2, so that one checks out. Now let's try the other one. Square root of 2 times negative 4 plus 12, that's going to be negative 8 plus 12, so that is square root of 4. Square root of 4 is 2. 2 minus 2 is 0. But this says that 2 minus 2 is negative 4, so that one's false. So what that means is that this one is an extraneous solution. You still need to write extraneous. I mean, you don't need to write extraneous. You still need to write x is equal to 2 or x is equal to -4, but to get full credit at the end, you don't have to show the work of checking. You can either do that in your head or on scratch paper. You are welcome to include it if you want to, but your final solution should just be 2 without including the -4, okay? So you want to reject -4 because it's an extraneous solution and just include 2 for your final solution. Okay, so for number 16, we have a 45, 45, 90 triangle, and we are told that side A is equal to 4. We need to then find B and C. Now, on the test, I do give you the version of the problem that has the formulas, just like you see there on practice test 3. I'd prefer you actually understand what's going on and use reference triangles, but for the sake of time and efficiency right now, I just decided to hand you the formulas. But one thing you should know is that because it's a 45, 45, 90, it's an isosceles triangle, meaning that the two legs are going to be congruent. So you don't need to have any special formula for that. B would also equal 4. Okay, so anytime you have a 45, 45, 90 triangle, the legs are congruent. Now, of course, you can get C by using the Pythagorean theorem, but the fast way to get C, the formula for C is you just take one of the legs and you multiply it by the square root of 2. So the hypotenuse of a 45, 45, 90 triangle is always square root of 2 times one of the legs. So in this case, you just take the value 4 and multiply it by the square root of 2, and that's it. So this should be a really easy problem. If you have one of the legs, the other leg is identical, and to get the hypotenuse, you just multiply by the square root of 2. So don't use a decimal approximation, use these exact numbers, type in 4 square root of 2, and you get that one right. That's 16. It does not require any work. Number 17 is similar in that we are dealing with the right triangles again, but this time in number 17 you have a 30, 60, 90 triangle. And you are given the value for B, which is the medium leg. Okay, the short leg is always opposite the 30-degree angle. So the little side is always opposite the little angle. The medium side is always opposite the medium angle. And the biggest side, the hypotenuse, is always opposite the right triangle, the largest angle. So to get A and C, you can use the formulas. And to go from the medium side to the short side, it's always the same. You divide by the square root of 3. This side is always going to be the square root of 3 times this side, okay? So to go from the short one to the medium one, you multiply by the square root of 3. To go from the medium one to the short one, you divide by the square root of 3. And it actually says that in the formulas. You see that there's a formula that says that A is equal to B divided by the square root of 3. So I gave that to you right there on the test. So to get A, we simply take 10 and divide it by the square root of 3. You will need to rationalize the denominator, so you'll need to multiply by the square root of 3 over the square root of 3, and so the final answer that you're going to type in is 10 root 3 over 3. So that will be your final answer. Now, once you get A, C is always 2 times A. In a 30, 60, 90 triangle, the hypotenuse is always twice as long as the short side. That's a special feature of a 30, 60, 90 triangle. So to get this value, all you have to do is multiply A by 2. And if you double 10, you get 20. So this is 20 root 3 over 3. And you're done. That's it. That's all you have to do. So you don't have to show any work. You can use the formulas. If you want, you can use the reference triangles. You can have those on your page of notes. set up proportions, that would be a great way to do it. But if you just want to use the formulas I have provided for you right there on the test, then that's also a totally fine way of doing that. So make sure, though, that you give me exact answers, rationalize the denominators, don't give me decimal approximations. All right, question number 18 is another one that requires you to show your work. So question number 18 is the laptop problem, and it requires you to use the Pythagorean theorem. So in question number 18, we're told that we have a 19-inch laptop, and it says this in the problem, but you're going to remember that when you have a computer screen or a TV screen, when they say it's a 19-inch screen, what they mean is that from one diagonal, from one corner to another corner, along the diagonal is going to be where they're measuring. Okay, so this is a 19-inch laptop screen. Now, of course, a laptop screen, like a TV screen, is going to be a rectangle. So when you split the rectangle in half, you end up with two right triangles. And we need to figure out how wide the screen is. And the width is going to be this part right here. Sometimes you might think of the width as the shorter one and the length as the longer one. But the width in this case is going to be the part that goes sideways when you're looking at it as a laptop. Remember, as a laptop, you're always going to have this long rectangle this way, and the width will be down there. So just use your common sense about computers. So this is the part that we need to know right here. The width. We know that the height is 8 inches in this problem. Your problem is going to have different numbers, but it'll be the same concept. The height of the screen is 8 inches. So to get this, you're just going to show me the work of using the Pythagorean theorem. You also know, you do need to show me a diagram, okay? So as part of your required work, you're going to draw a diagram, and you're going to label your diagram, okay? So make sure you draw the diagram and label it, and then you're going to show me your Pythagorean theorem equation. So in this case, 8 squared plus w squared is equal to 19 squared. 8 squared is 64, so you just take 19 squared and subtract, okay, I totally messed that up. Okay, 19 squared minus 8 squared is 297. So w squared is 297. Then you're going to take the square root of both sides. In this case, you do not need to do plus or minus because it's a laptop width. There's not going to be a negative width. So just a positive one. W is equal to the square root of 297 inches. That's the exact answer. That's the first answer you're going to provide. And then it says to give to 2 decimals an approximation. So this is going to be 17.23 inches. Just make sure you round correctly. All right, so that is number 18, and that requires work on the test. For number 19, you are not required to show your work, so you can choose to either use the distance formula or the Pythagorean theorem, but the problem is to find the distance between the two given points. If you want to use the distance formula, you're welcome to have that in your notes. So the distance formula is going to be the square root of the difference between the x-coordinate squared and the difference between the y-coordinates squared. So in this case, you're going to end up with 2 squared plus negative 3 squared. So that's going to be 4 plus 9 square root of 13. And you give an exact answer. Now the other way you could do this is to use the Pythagorean theorem by plotting these points -1, -2 is right here, and -3 positive 1 is right here. The distance between those 2 points is the length of the segment. The vertical distance between a positive 1 and a negative 2 is 3. The horizontal distance between negative 3 and negative 1 is 2. And so you have 2 squared plus 3 squared is equal to c squared. So 4 plus 9 is equal to c squared. 13 is equal to c squared. C is equal to the square root of 13. So either way you do it, you're going to have the square root of 13 as your answer. It's up to you if you want to use the distance formula or if you want to use the Pythagorean theorem. You can even do it in your head. No work is required for that one. Number 20 is another problem that requires work. This says that an object dropped from a height of 230 feet will fall according to the equation h of t is equal to 230 minus 16t squared. So your equation will also say negative 16t squared because of being on Earth and the gravity is going to have the same acceleration. But the number right here, 230, will change. So there are two questions. One, what is the height of the object after a certain amount of time? And then how long will it take the object to hit the ground? In this particular version of the problem, it wants to know what is the height after 2.3 seconds. Now, 2.3 seconds is time. So to get the first answer, I simply plug in 2.3 for t. So this is the work that you would show. You would show plugging in 2.3. You need to plug it in on the left-hand side for t and the right-hand side for t. You will have a different value for time. Well, you may have 2.3, I don't know. But whatever value you have, you just plug it in like that, and then you can use the calculator. You don't have to show me the work of simplifying it. You just have to show me plugging it in. And then 230 minus 16 times 2.3 squared. This one, it says that we can round to 2 decimal places. And so we should end up with 145.36. And we're going to label that as feet. And every time you show your work on paper, you also still enter your answers online. Make sure you do both, okay? So you have to answer online and you show your work, and those answers should match. For part B, or the second question, it says, how long until the object hits the ground? That question, how long till the object hits the ground, let me separate these questions, requires that you take the height and make it 0, because the height of the ground is 0. So we're going to take this original equation right here and replace height with 0. And because this object is dropped, it does not have an initial velocity of anything other than 0, which is nice because it's set up for you to solve using the square root property. So you get your perfect square on one side, and then you take the square root of both sides. Now 16t squared is a perfect square, so you can go ahead and take the square root right here. Alternatively, if you want, you can just rewrite this as t squared is equal to 230 divided by 16, because we get the t squared by itself. So take the square root of both sides. We are looking for positive only. Don't do plus or minus here because we're looking for positive time. You can then take 230 divided by 16, take the square root of that, and you get a decimal approximation. Remember, you get to round to 2 decimal places, so I have 3.79, and that is in seconds. What that means is it takes 3.79 seconds for the object to hit the ground. You round to 2 decimal places. Okay, so that was question number 20, and the next question, number 21, also requires that you show work, and this one is also using the square root property. number 21 also requires you to use the square root property, and you're going to show your work. So to use the square root property, what we want to do first is get the perfect square by itself. This is already a perfect square. It's a polynomial that's being squared. So you can go ahead right now and take the square root of both sides. Show this. Show the square root sign on both sides. And it's also critical that you show the plus or minus sign. We didn't do that in the previous problem because we were looking for time, and time was going to be non-negative. But in this problem, we could have a positive or a negative answer, or both. So we're going to take the square root of both sides and include this plus or minus symbol here. That's very important. This leaves you with 4k minus 8 is equal to plus or minus 81. Of course, the square root of 81 is 9. So now you're going to add 8 to both sides. Plus or minus 9 plus 8 is not plus or minus 17. Plus 9 plus 8 is 17, but negative 9 plus 8 is negative 1, okay? So you're going to have two different values here. Positive 9 plus positive 8 is 17. Negative 9 plus positive 8 is negative 1. Now divide both sides by 4. K is equal to 17 over 4, or negative 1 over 4. So you will write those in as reduced fractions online, as well as providing all of your work here. Okay, so that's question number 21. Question number 22, you don't have to email me your work because it's already going to be broken up for you online into multiple steps. So what we're going to do is complete the square. Oops, equal sign. Okay, so what they have is they have a box here for you to fill in and a box here for you to fill in. So what we're doing in this first step is we are adding the same value to both sides that is going to create a perfect square for the left-hand side. And it's going to be the same number, the same formula for this. You're going to take b, you're going to divide b by 2, and you're going to square it. So you add that same value to both sides. So what is b in this case? B is negative 16. Negative 16 divided by 2 is negative 8. And then when you square that number, you get 64. So for that first line of work, you plug in 64 to both sides. And then it says after factoring and simplifying, what does the equation become? So you have to factor. It says after factoring and simplifying, you then have to fill in these other two boxes. Of course, simplifying, negative 53 plus 64, when you simplify that, you get 11. But on the left-hand side, we're supposed to factor this. And the factorization here is always going to be x plus b quantity squared. It will always be that. So we have x. B, though, is a negative number. B is negative, x plus b over 2. Wrote that down wrong. Let me fix that. This is x plus b over 2, always. So b over 2 is negative 8. You can test that this is correct. Just take this and square it, and you should get this. That will be the same thing, okay? So make sure that this squared is equal to that. So that's the after factoring and simplifying, and then you're supposed to solve. So you don't have to show the work of solving. You just go ahead and do the work on your scratch paper. But when you take the square root of both sides, you end up with x minus 8 is equal to plus or minus square root of 11. And then that becomes x is equal to 8 plus or minus the square root of 11. So this is what we have for the next answer. It actually wants you to list it, though, as two separate answers. So what that means is for your box, it says x is equal to you have one box, and you have another box. It's always good to write the smaller one first. So that would be 8 minus root 11 and 8 plus root 11. And then for the last part, you do your decimal approximation. So x is equal to, and so here are your two boxes that you use for your decimal approximation. So you type that in the calculator. You have 8 minus the square root of 11, and that is 4.683. Oh, 10 thousandths. Here's your tenths, your hundredths, your thousandths. Your 10 thousandths is going to be one more decimal place. Okay, so for this one you need to go 4 decimal places. That's the 10 thousandths place. 8 plus root 11 is going to be 11.3166. Okay, so let me just make sure that I have these. Alright, so so you got 8 minus root 11 and 8 plus root 11, so that's 11.3166 and 4.6834. Alright, that was problem number 22. Now, for problem number 23, you don't have to show your work because you're just plugging in the values to the quadratic formula. Okay, so for this question, you just need to plug in the values of A, B, and C into the quadratic formula. The quadratic formula is x equals negative b. So negative b, instead of having a positive 5, you put in negative 5, plus or minus b squared, and you don't have to put parentheses in, I checked it, minus 4ac all over 2a. So it's a really straightforward question. You just need to plug in the values of a, b, and c into the formula, except right here, this is a negative b, so you want to plug in a negative 5. So you get negative 5. Okay, so this one will be a negative 5, but other than that, this will be b, a, c, and a, just like the formula. For number 30, you have a multiple choice, 24, number 24. You have another quadratic formula question, but this one is multiple choice. So I'll just do it as a short answer though. You're supposed to use the quadratic formula on number 24, okay? So remember, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's not provided for you on the test, but you can include that in your notes. So since a is negative 3 and b is 7 and c is 3, I can rewrite this as x equals negative 7 plus or minus the square root of 7 squared minus 4 times negative 3 times 3 all over 2 times negative 3, which becomes negative 7 plus or minus the square root of, this is 49, so we have 49 minus minus will be a plus, so that will be 9 times 4, which is 36. So that is the square root of 85 over negative 6. And so that one is going to be the first answer choice came up. And yeah, so in this case it happens to be answer choice A, but that's as far as they simplify it. So pretty straightforward there. Should be easy enough. Okay, so for question number 25, you're given an equation in vertex form, and you're told to find the vertex. Remember that anything written in vertex form, you can identify the vertex easily by just looking at these two values. The vertex is always going to be h comma k. So you look here, and you're going to take the opposite of this number. So the opposite of this number, -1, would be +1. And then you take the k value, whatever it is. Another way you can do it is to say that this parabola has shifted to the right 1 unit and down 2 units, giving you a vertex of 1, -2. So make sure you use parentheses, have your correct notation. All you have to do is put your vertex in. There's no work required. For question number 26, you're supposed to find the y-intercept. The y-intercept is not 3. This is not the c value. This is not written in ax squared plus bx plus c. So remember, anytime you want to get a y-intercept, you plug in 0 for x, and whatever you get for y, that's your y-intercept. So plug in 0. So if this function f of 0 is equal to 0 plus 8 squared plus 3. So 8 squared is 64. 64 plus 3 is 67. So 0, 67 is your y-intercept. Okay, in number 27, you are given a parabola. This is the parabola that I've pulled up for my version of it. You only have to show your work for part D. But here's part A. Part A, you need to find the value of f of -4. You can just plug that into the calculator. You don't have to show the work. So if you plug -4 into the calculator, you have negative, then you have parentheses, -4 squared minus 14 times -4 plus 11. So you may want to go ahead and try typing that into your calculator in the same way. You can't see my full line here. Anyway, but when you type it in, when you type it in, you get 51. No work required. You can do that on the calculator. Part B, the vertex. You can also do this on scratch paper. But the vertex formula, you have -b over 2a gives you the x value. And so in this case, since b is -14, -b would be +14, divided by 2a. A is -1. So this is +14 divided by -2, which is -7. That's the x-coordinate of the vertex. To find the y-coordinate of the vertex, you plug in -7 into the function. So again, you can do this with the calculator. And you get 60. So that means that the vertex is at the point -7, 60. So then next you need to know the y-intercept, and the y-intercept is really straightforward because the y-intercept is always the same thing as c. So in the original equation, the c value is 11. Remember, to find the y-intercept, you just plug in 0 for x. So since f of 0 is 11, that tells you that the y-intercept is 0, 11. Make sure that you write it as a point. It says part C, the y-intercept is the point. Type in 0, 11 using these parentheses too for your complete point notation. Now, for part D. Part D, you have to show your work and email it to me. You need to find the two values that make f of x 0. So for part D, find the values of x that make f of x equal to 0. This is the same thing as saying find the x-intercepts. So you just replace f of x with 0, and you're left with a quadratic formula problem. So this is where you're going to show me how to use the quadratic formula in your work. So x is equal to negative b plus or minus the square root of b squared. Make sure you have parentheses here if you have a negative number. Minus 4ac. This radical needs to cover the entire expression here, all over 2a. And this simplifies to 14 plus or minus the square root of, 14 squared plus 44 is 240. And we need to simplify this further. 240 is divisible by 16. It's 16 times 15. That's an optional step right here. Okay, so that's optional, but you do need to go on to 14 plus or minus 4 root 15 over negative 2, and then you can factor out a 2 from the numerator, or rather a negative 2 from the numerator. And so your exact answer is negative 7 plus or minus 2 root 15. So you have to make sure that you can show all that work on your own. You're going to give an exact answer, and it needs to be fully simplified. So go through it and give an exact answer that is fully simplified. Okay, next, number 28. Y is equal to negative x plus 2 squared plus 2. You need to graph it. So, sorry, you can see it now. Number 28, y is equal to here. Okay, so you need to select the parabola picture. The parabola picture is going to look like this. So first select the box on My Open Math that looks like that. Once you've selected that, you just need to plot 2 points. Now, notice that the vertex of this is at negative 2, 2, right? You take the opposite of this number and then that exact number, and that becomes your vertex. You can also get that by observing that the graph shifts to the left 2 and up 2. So that's left 2, up 2. So once you know your vertex, you're going to plot that point. So at negative 2, 2, you plot one of your 2 points. So you just put a dot right here. Then for your second point, you can pick any other point. And so it might be easy just to find the y-intercept, for example. If you plug in 0 for x, you end up with 0 plus 2 squared, which is 4. You have negative 4 plus 2, which is negative 2. So that tells you that the point 0, negative 2 is on the graph. So with the little pencil there on My Open Math, plot another point at 0, negative 2. And the good thing there is it will automatically fill in the rest of the graph for you. So as long as you starts with the vertex and then plot your second point, I recommend the y-intercept, and then it will go ahead and fill in the rest of the graph for you. So that's all you have to do for number 28. Number 29 is the last question on the test. You don't have to show work, but it walks you through a lot of steps. Okay, so first of all, the parabola given in my version is f of x is equal to x squared plus 2x plus 3, and you first have to determine if it faces upward or downward. So because here I have a positive number, when this number A out in front is positive, that's going to be up. So I don't know if yours is going to be up or down, but I'm selecting up because this is a positive number. If you have a negative leading coefficient, you get down. Okay, and then for part B, you just need to fill in the table. And so for mine, this is what I ended up with. So there's a table that's given to you. All of the x values are already plugged in, and you just need to plug in each of these x values into the function. You can use your calculator, you can do it in your head, and then you bring all of these together. And one thing I did when I was done is I looked at the place where I see symmetry. You see here it goes 6, 3, 2, and then it starts turning around and goes back up again, 3, 6. So I see symmetry here. What that means is that's the vertex. And I double checked that I did that right by actually finding the vertex using the vertex formula. Remember that the vertex formula has you find negative b over 2a, and that is the x-coordinate of the vertex. So in this case, negative b is negative 2 over 2a. So what is that? Negative 2 divided by 2 is negative 1. So as I would expect, negative 1, and then you plug in negative 1 and you get 2, that's the vertex. So you should have your table validate your algebra when you use the formula for the vertex. The formula for the vertex should give you the same value as your table, and you should see the symmetry in your table. So that's actually part D. Part C is you're going to graph it. So when you graph it, remember you only need to plot 2 points. Just make sure you pick the parabola looking shape. It's okay if the parabola looking shape, if the icon for the parabola is an upside down parabola, but your parabola is upright, that's okay. Ultimately, you just need to pick the right shape. Don't pick a line or the absolute value or a circle. Make sure you pick the parabola. And then I'm just going to plot 2 points. So negative 1, 2. That's my vertex. So that would be my first point. And then for my second point, 0, 3, that's my y-intercept. So that's a good point. So always do the vertex as your first point. Always use the vertex as your first point, and then it will automatically graph the rest of the curve for you once you have those 2 points. So that was part C. So part A is up or down, part B is filling in the table, part C is graphing it, and then part D is finding the vertex, and part E is identifying the y-intercept, okay? So the y-intercept, we already just said that, what the y-intercept is. The y-intercept is on the table where 0 is x. You see the value 3 is y, so the y-intercept is 0, 3. So you don't have to show me the work for this because it's already split up into lots of multiple parts. But that is the last question there on the test. So each of the test questions, as you are completing the practice test, it will tell you how many points those questions are worth. So pay attention to the questions that are worth a lot of points. Make sure that you can do those questions well. Don't say, I don't know that concept, I'm just going to skip it, because some of the questions are worth a lot more points than other questions. So pay attention to the points. And then also realize that the score that you get when you submit it online is not your final score. That's your preliminary score, but it can be adjusted up or down based off the work that you send in the email. So you do have to type in all of your answers online and send it just like it's a quiz, but then you will also need to send me your written work, legible, organized written work for the questions that I told you you need to send me the work for. And those questions are actually listed in the instructions. It says for questions 10, 13 through 15, 18, 20, 21, and 27D, you're going to send me the work. And you will have half an hour after the test closes, or half an hour after 11:45, so 12:15, to get it to me. Just make sure you read all the directions on the practice test before the test, and that will save you time on the real test. If you have any questions, please email me.